Good morning to one and all. I am Parthiban, working as assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Now I am going to present about the topic called electron devices, which is coming under the regulation R 2025. The subject code is EC25C01. Particularly, I am going to talk about the Unit 5. In the Unit 5, I am going to deal with light emitting diodes as well as LCDs. So, what is LED? LED is a semiconductor PN junction diode that emits visible or invisible light when it is forward biased. Unlike an ordinary diode that converts electrical energy into heat, the LEDs convert electrical energy directly into light energy through the process of called electroluminance. So the LED is an optoelectronic device because it converts electrical into optical radiation. So the historical background, we can say the modern LEDs produce red, green, blue, yellow, white, infrared or ultraviolet rays. The advantages are it is having a very less power consumption, high efficiency, small in size, as well as fast switching speed, long life, and then rugged construction, as well as low operating voltage. It is a very much environment friendly. So the basic construction we can say the LED is nothing but having a direct band gap semiconductor materials because these materials efficiently emit photons during the electron hole recombination. The commonly used materials are called gallium arsenide, gallium phosphate, as well as gallium arsenide phosphide. These are the primary components that we can use for LEDs. So LEDs can be of P type, N type, or PN junction type, or reflective type. So the working principle we can say the LED is working on the principle of, as I already told you, electroluminance, which is the emission of light due to electron hole recombination. So you see in the step 1, when it is forward biased, the P side connected to the positive terminal, N side connected to the negative terminal, the electrons move from the N region towards the junction, the holes move from the P region towards the junction, the electron and holes recombination at the junction. So during the recombination, the excess energy is released in the form of photons. So the color of emitted light depends on the band gap energy of the semiconductor material. So the energy band explanation gives the color of photon or emitted photon. So E is equal to HFE. So E is equal to HFE indicates the photon energy with the Planck's constant and the frequency of light. So these are the primary characteristics that we can see. Then coming on to the LED characteristics, which is nothing but the IV characteristics or VI characteristics we can say that resembles as if like that of PN junction diode. So you see in the x-axis we are having the forward voltage, in the y-axis we are having the forward current that is in milliamps. So for various colors you can see the variation. So initially when the current is very small, after the threshold voltage the current increases rapidly, typically the forward voltage. So the red LED is around 1.6 to 2 volts, the green LED is around 2 to 2.4 volts, and the blue LED is around 3 to 3.5 volts, and the white LED is 3 to 3.6 voltage. So reverse voltage rating is generally less than 5 volts. The special distribution curve we can see from the light intensity versus wavelength. So each LED light emits over a narrow wavelength range. For example, red 650 nanometers, green 560 nanometers, yellow 590 nanometers, blue 470 nanometers. So the very high current may cause heating and efficiency reduction as well as reduced lifespans. So these are there is a directional characteristics will also be there. LEDs lights are highly directional. The intensity depends on the viewing angle. So based on this only the LEDs will have the projection. This property makes LED suitable for indicators as well as for display applications we can see. Then another important LED parameters or characteristics features are actually we can say it is a speed spectral emission, that is a wavelength at which the LED emits the maximum optical power. Then spectral bandwidth, the range of wavelengths over which the LED emits lights. Then the radiant intensity, the optical power emitted in a particular direction, that is measured in megawatts per steradian. Then quantum efficiency. So the ratio of emitted electrons or photons to the injected electrons. So higher efficiency means a lesser electoral power that is wasted. Various applications of LEDs indicates. So LEDs can be widespreadly used for as a TV indicators, as well as in remote controls, as well as in mobile phone flash, as well as in digital clocks, as well as in automotive application as headlights, as brake lights, as dashboards. Particularly, it can be also used for optical communication as well as medical applications, so industrial application, domestic applications. So it has the widespread advantage because of the advantage lies in the form of efficiency, low power consumption, long life and reliable, compact as well as high switching speed. So these features makes LED very suitable for all the applications. Next, we are going to see about the LCD. That is another display device that we can say. It is called a liquid crystal display. LCD is a flat panel display device that controls the transmission of light using liquid crystal modules. Unlike LEDs, LCDs do not produce light. They modulate light from the backlight or ambient source. The LED crystals possesses the properties of solids as well as liquids. The flow like liquids but maintain a molecular alignment with crystals. The type of liquid crystals that we can say, the PPT classifies the liquid crystals into three types. One is pneumatic, another one is pneumatic, third one is cholesteric. So among these, the TN, that is called twisted pneumatic liquid crystals, are mostly used in LCDs. Coming on to the construction of LCD, we can say the LCD display consists of a front polarizer, a rear polarizer, a front glass plate, a rear glass plate, a transparent electrode, the liquid crystal layer, the segment electrode, and the backplane electrode. So these are the primary parts of LCD. So coming on to the working principle of LCD, LCD works by controlling the polarization of light. Without applied voltage, the liquid crystal molecules are twisted. They rotate in the plane of polarized light. The light passes through both the polarizers. The display appears as if like bright. So with the applied voltage, the molecules align with the electric field. The polarization is no longer rotated. The light is blocked by the second polarizer. The display appears dark, thus applying voltage controls the visible image. The applications of LCD are used includes the digital watches, calculators, mobile phone, laptops, computer monitors, television, medical equipments, industrial control panels, automatic industrial instrument clusters. So the primary advantage of LCD are very low power, thin and lightweight, low heat generation, very good image quality, longer lives, suitable for battery operated devices. The limitations goes in the form of it requires the backlight in the environment. It is having the very limited angle. It shows a response compared to LEDs and OLEDs. The slower response is one of the primary disadvantages of LCDs. The contrast ratio is very much slower than the or lower than the OLEDs or LEDs, whatever it may be. The performance is extremely affected by the temperature also. It is, we can say, it is a temperature sensitive device. So these are the important things that we have to note into that. So LCD is primarily used for displays as well as in screens, whereas LED is used for lighting as well as for indicators. These are the various references that I used to have. So thanking you one and all for hearing my lecture very patiently. So once again, thanks a lot.